Interpreting growth patterns. How can we analyze trees to learn about growth patterns? This week, we'll learn how scientists interpret the growth patterns of trees. Our learning goals are: I can interpret the growth pattern of a young tree. I can make inferences from observations of tree cross sections. Our language goals are: I can talk about trees using words like tree rings, tree cookies, bark, sap, xylem, phloem, cambium, heartwood, and sapwood. How can we learn about the life of a tree? Trees grow well if the outer bark is healthy, the leaves are healthy, there's a lot of sunlight, there's enough water, the soil is healthy, there aren't too many other trees close by sharing the space, water, and light, and if the area is not polluted. So as you can see, trees can be healthy when the conditions are right. They need sunlight, water, and not too much crowding as well. And pollution is damaging to trees just as it is for other forms of life. Trees don't grow well if their outer bark is hurt by insects, fire, or other damage. The leaves are hurt by insects, weather, or other damage, including being eaten by lots of the consumers that like to eat leaves. If they overfeed, that can be quite stressful and damaging to the trees. So there has to be a good balance. They don't grow well if there's not enough sunlight. Now, that's not always caused by weather. It's often caused by being crowded out by taller trees taking up their resources like sunlight and water. Sometimes the lack of water is caused by competition with other trees and plants. Sometimes it's caused by drought, which is a weather condition. If the soil is unhealthy, it's hard for trees to grow well because that's where they get many of their nutrients from. And again, they can be crowded out if there are too many other trees close by sharing the space, the water, and the light. And again, if the area is polluted, that can really impact how well a tree grows. Now we're going to take some time to learn about a really cool branch of science called dendrochronology. And if we break that word down, we could take the word dendro, which means tree, and chronology, which means time or measuring time. And we can kind of figure out maybe what dendrochronology might be about. Dendrochronology is the scientific study of growth patterns and the aging of trees as shown by their rings. Once a tree dies, falls over, or is cut down, looking at a flat circle or a cross section of the trunk can tell us a lot about what happened to the tree as it grew. Flat circles cut from the trunk of a tree are often called dendrodiscs or cookies, and they have one ring for each year of the tree's life. Tree rings are like the growth chart of a tree. Easily visible rings can provide information about the weather, soil, and light conditions over time. There are 4 main characteristics to look for on a tree cookie. 1, a center ring where the tree was first born, and pay attention to where the number 1 is pointing in this illustration. It's pointing to the very, very center, and that's the first year of growth of this tree. Number 2 is wide rings that show when the tree was healthy and grew a lot, pointing to these wide rings here. So that means the conditions were ideal. Plenty of sun, plenty of water, healthy soil, not too much pressure from other trees in the environment or pests like insects, or overfeeding by consumers. Number 3, thin rings that show when the tree was unhealthy and grew poorly. And you see this number 3 pointing to these thin rings in the early years of this particular tree's life. And finally, number 4, scars. Scars show where the outer bark was hurt or damaged and the tree's growth was affected. What can we learn from looking at tree cookies? Trees grow from the center outwards with a ring representing each year. So newer rings are farther out on the outside from the earlier rings. Rings that are farther apart often indicate that growing conditions were very good that year and there was lots of light, space, and moisture. Rings that are closer together often indicate that growing conditions were not as good that year. A blackened area could indicate a fire that the tree survived. Small black spots often indicate insect or bird damage. When tree rings are closer together at one side of the tree, that can indicate that the tree was growing at an angle because something was in its way, or it was growing on a hillside. In this case, the rings would be compressed on the uphill side of the trunk. So in this area, you can see these rings are compressed close together and they are spread farther apart on the other side. That means that this was either growing on a slope, and this is the uphill side, or it was very crowded by other trees on this side and it did not get as much light and water as it should have, whereas on this side it got better light and water. When branches are removed from or fall off of trees, there's typically a scar left that has a V shape that continues from the point where the branch was all the way to the edge of the tree. So you can see if this tree had continued growing, this scar would have formed a complete V where this branch was lost. It would have come right around it, and you can see the beginnings of the V shape forming. Let's review what we've learned in this video. Cross sections of tree trunks, also called dendrodiscs or tree cookies, can be analyzed to help us determine the age of trees and important events that have happened through their lives. And there's lots of very important information that scientists can get from that, not just about the tree, but about our history. It can tell us about the history of weather events in our areas, the history of insect infestations, of forest fires, and a lot more. And when you think of how long some trees can live, hundreds of years, many times longer than people, studying dendrodiscs can really give us some cool information about our past. Each ring in a cross section of a tree trunk denotes 1 year of growth. And we know that we have the early growth, which is lighter in color, and the late growth, which is darker in color. Growth in a ring may be asymmetrical. So asymmetrical means uneven, not the same on both sides. So that may be caused by things like being crowded on one side, growing on a slope or a hill, possibly having damage to one side of the trunk. Early growth in the spring is observed as having a lighter color. I mentioned this just a minute ago, while late growth from the autumn is observed as having a darker color. Scars indicate that growth was damaged in some way, whether it's from insect or bird damage, from a fire, or from the loss or injury to a branch, or some other kind of injury to the bark itself. And that is our overview of what we can learn about studying the growth patterns of trees, and how we can interpret them to learn about the life cycle of a tree.